Welcome back, students. I hope you all have gone through my last video of master electrolysis in 40 minutes. I hope the concepts are clear in the chapter electrolysis. Now we are going to move on to the next chapter, chapter 9, practical chemistry, where we are going to cover in part 1 all the gases. As you can see on the screen, 10th ICSE Master ICSE Chemistry MCQ Practical Chemistry Part 1. Let us start with first question. What of the following is a neutral gas that turns white anhydrous copper sulfate blue? The options are chlorine, ammonia, water vapor, hydrogen chloride. The correct answer is water vapor. Now students, you should not only know the answer, you should know the chemistry behind it. So let us take the explanation. Water vapor turns white anhydrous copper sulfate blue. So copper sulfate, which is anhydrous, is used for detection, or I can say identification of water vapor. There's one more reagent we can use is cobalt chloride paper, which turns pink. So it turns blue cobalt chloride paper pink. I hope this MCQ is clear. Let us move on to the next question. Question number 2. The gas that burns with pale blue flame producing pop sound. A very common question which you have seen from class 6. Options are oxygen, hydrogen, carbon dioxide, nitrogen. Yes, you have done this entire chapter in class 9, hydrogen. Let us take the explanation. Hydrogen gas is neutral to litmus, colorless and odorless. When a burning splinter is introduced, hydrogen burns with pale blue flame and produces a characteristic pop sound. I hope this is clear. Let us move to the next question. Question number 3. Which gas rekindles a glowing wooden splinter? This is a very common question again. Hydrogen, carbon dioxide, oxygen, nitrogen. And you all know the answer, I know that. Correct, oxygen. Oxygen supports combustion. A glowing wooden splinter rekindles or bursts into flame when introduced into the jar containing oxygen gas. I hope this is clear. Let us move to the next question. Question number 4. Oxygen gas is absorbed by lime water, acidified potassium permanganate, colorless alkaline pyrogalol solution, lead acetate solution. The option is colorless alkaline pyrogalol solution. Alkaline solution absorbs oxygen and turns brown. So this solution can be used to identify oxygen gas. This is a specific test for oxygen. Let us move to the next question. Question number 5. Which gas turns lime water milky but has no effect on acidified KMnO4 or K2Cr2O7? Their options are sulfur dioxide, hydrogen sulfide, carbon dioxide and chlorine. Let me tell you student, KMnO4 is potassium permanganate and K2Cr2O7 is potassium dichromate. The option is carbon dioxide. Let us see. Carbon dioxide turns lime water milky due to the formation of insoluble calcium carbonate. But to identify it, if it is passed through KMnO4 or K2Cr2O7, okay, it is not affected. So KMnO4 and K2Cr2 are the reagents which distinguish carbon dioxide from sulfur dioxide and H2S, that is hydrogen sulfide. So KMnO4 and K2Cr2 are the two reagents which helps you to distinguish between carbon dioxide, sulfur dioxide and hydrogen sulfide. Let us move to the next question. Question number 6. The milkiness produced when carbon dioxide is passed through lime water disappear on passing excess carbon dioxide because calcium carbonate decomposes, soluble calcium bicarbonate is formed, carbon dioxide evaporates, calcium oxide is formed. Students, in the beginning lime water turns milky, but if you pass excess carbon dioxide it becomes colorless. Because of what? Because of, let us take the explanation. Initially calcium hydroxide, that is lime water, when it is treated with carbon dioxide it will form calcium carbonate, which is a reason for milkiness. But if you continue passing carbon dioxide in the same solution, what will happen? Calcium carbonate will further react with carbon dioxide and this time it forms calcium bicarbonate. Calcium carbonate is an insoluble salt wherein calcium bicarbonate is a soluble salt. So here the milkiness is because of CaCO3 and it disappear because of the formation of calcium bicarbonate. This is the chemistry behind milkiness. So you are learning this from class 6. But the reason why it become milky and in excess why the milkiness disappear, now you have learned. I hope the concept is clear. Let us move to the next question. Question number 7. Which gas turns acidified potassium permanganate from pink to colorless? Other than this, nothing is mentioned, students. Pink to colorless. Options are carbon dioxide, sulfur dioxide, hydrogen and oxygen. Two options are very weird. Yes, the option is sulfur dioxide. Now many students say, Miss, something is clear, that clear colorless is not mentioned. Okay, colorless is enough to answer. If anything else is mentioned like yellow particle, then sulfur dioxide won't be the answer. This data is enough to identify sulfur dioxide. So let us take the explanation. Sulfur dioxide is a reducing agent. It reduces KMnO4 to MnSO4. The reaction you can see. If observation question is asked, there is no need to write the equation. Fine. This is just to make your concept clear. KMnO4, what was before reacting with sulfur dioxide, was purple. As soon as it is reacted with sulfur dioxide, it is no more KMnO4, it is MnSO4, which is colorless. I hope the chemistry behind this is clear. So answer is sulfur dioxide. I hope this is clear. Let us move to the next question. Question number 8. When sulfur dioxide is passed through acidified potassium dichromate solution, the color changes from green to orange, orange to clear green, pink to colorless, colorless to brown. First of all, student, you should know the original color of potassium dichromate. Orange to clear green. Okay, students, orange is the original color. When it reacts with sulfur dioxide, it will form green color and that is clear green. Got it? So sulfur dioxide reduces orange potassium dichromate to green, and that green color is because of whom? The green color is because of formation of chromium sulfate. Again I repeat, if this question is asked in observation, okay, no need to write the equation, you can write orange to clear green. So the MCQs made by me can be asked as MCQ and they can be asked as observation. If you are prepared, it can be in any form of question. You will be in a position to answer the question. I hope this is clear. Let us move to the next question. Question number 9. The compound responsible for green color when sulfur dioxide is bubbled through acidified potassium dichromate, that is K2Cr2O7, is potassium sulfate, chromium sulfate, sulfur dioxide and potassium dichromate. Original color of K2Cr2O7, I hope you know, it is orange. The answer is chromium sulfate. Originally K2Cr2O7 was orange in color. As soon as it reacted with sulfur dioxide, it is no more K2Cr2O7. After the reaction, the product form is chromium sulfate, which is green in color. And this reagent is used for identification of sulfur dioxide. I hope this concept is clear. Let us move ahead. Question number 10. Which gas has suffocating odor and turns moist blue litmus paper red? We will be able to answer only when the options are displayed: oxygen, hydrogen, sulfur dioxide and ammonia. Two options are very weird. Sulfur dioxide. Sulfur dioxide is what kind of gas, students? It's an acidic gas with characteristic suffocating odor. It turns moist blue litmus paper red. In the beginning I told you two options are very weird, that is option A and B. They are neutral gases. And D is basic gas, that is ammonia. I hope this is clear. Let us move to the next question. Question number 11. Chlorine gas is colorless with pungent odor, greenish yellow gas with pungent odor, colorless gas with rotten egg smell, and reddish brown gas. Some options are very weird. Yes, this is the first gas we have come across till now. It is greenish yellow gas. Chlorine is greenish yellow gas with pungent odor, suffocating odor. I hope this is clear. Let us move ahead. Question number 12. What happens when moist blue litmus paper is exposed to chlorine gas? It turns red permanently, it turns blue permanently, it turns red and then is bleached, it remains unchanged. One nature of chlorine, I'll let you know, students, it is bleaching agent. Oh, the option is clear now. Yes. Since it is acidic in nature, so it will turn blue litmus paper red. But since it is a bleaching agent also, so then it bleaches it changes the color, it fades the color. So let us take the explanation. Chlorine react with moisture to form HCl and HOCl. HCl turns litmus red, and HOCl, that is a compound which is formed intermediate, decomposes to give you nascent oxygen. And let me tell you, students, this nascent oxygen makes the reaction make the chlorine a bleaching agent which bleaches the litmus. I hope this is clear. So two types of reactions are taking place, one because of HCl and one because of HOCl. I hope this is clear. Let us move to the next question. Question number 13. Chlorine gas turns moist starch iodide paper red, green, blue, black, yellow. Let me make it clear, students. Starch iodide paper is a paper exclusively used for chlorine gas. Yes, blue, black. So the option is when chlorine is tested with, if you don't have litmus paper, you can go for moist starch iodide paper. That is also one option. We have to test chlorine. So it will turn blue, black. Let us see the chemistry behind it. When chlorine is treated with potassium iodide solution, starch iodide solution, okay, it will liberate iodine gas, okay, and react with starch to form blue black complex. If this question is asked as observation, students, you can write equation, but observation is enough to complete the question answer. Let us move to the next question. Question number 14. Which gas gives dense white fumes when glass drop dipped in ammonia solution is brought near it? The options are chlorine, oxygen, hydrogen chloride, carbon dioxide. It's a very common question asked in boards. Yes, the correct option is hydrogen chloride gas. Hydrogen chloride vapor react with ammonia to form ammonium chloride, which appears as dense white fumes. So densified fumes is formed when ammonia comes in contact with hydrogen chloride gas. I hope this is clear. Let us move to the next question. Question number 15. Hydrogen chloride gas passed through silver nitrate solution gives white PPT soluble in ammonium hydroxide, white PPT insoluble in ammonium hydroxide, yellow precipitation and no precipitation. It's a very common question asked in exam, and it comes under either it can come as MCQ or it come as observation question. Correct. The first option is the correct option. White precipitate is formed which is soluble in ammonium hydroxide. One more question can be framed over here. Which white PPT is soluble in ammonium hydroxide? Again I repeat, which white precipitation is soluble in ammonium hydroxide? Answer is silver chloride. Answer is silver chloride. So here hydrogen chloride gas passed through silver nitrate solution gives white PPT. It gives curdy white PPT. If in exam you just write white PPT, it is acceptable. So silver chloride, and if I want to know is this silver chloride or not, I will add ammonium hydroxide, and if it is soluble, it is confirmed that it is silver chloride. I hope this is clear, but it is insoluble in nitric acid. Revise this once again before going for your exam. Let us move to the next question. Question number 16. Which gas has rotten egg smell? Many times you have gone through. So this is a very common question. Even 6th standard child will answer. The options are sulfur dioxide, H2S, chlorine and ammonia. Answer is H2S. Hydrogen sulfide is characterized by its distinct rotten egg smell. Let me make it very clear. If it is asked under observation, okay, you cannot give rotten egg smell as a test. It's a physical test. Fine, but for this option, the H2S MCQ, this is correct. But if this question, if they ask you, give test for hydrogen sulfide, in that case, you cannot write rotten egg smell. It's a physical test. You have to give the chemical test for H2S. Let us move to the next question. Question number 17. Hydrogen sulfide gas turns moist lead acetate paper. So here we can see lead acetate paper is used as a reagent. The options are blue, red, silver, black or black and green. The option is silvery black or black. The explanation is when lead acetate paper comes in contact with hydrogen sulfide, it forms lead sulfide which is black in color. Again, if this question is asked in observation, what do you observe when lead acetate paper is treated with H2S? The observation is it gives silvery black or black PPT, change in the color. I hope this is clear. So these are the questions which are framed by me. They can come as MCQ, they can come as filling the blanks, they can come as match the column, they can come as observation question. Once you are well versed with your theoretical part, I guarantee you can answer any question asked in the paper. Let us move to the next question. Question number 18. When hydrogen sulfide gas is passed through acidified KMnO4, that is potassium permanganate, the color changes from pink to colorless, but the solution is clear colorless, not clear due to yellow sulfur particles, green, blue. Two options are very weird. What is the original color of KMnO4, students? It's pink. It's given here. Not clear due to yellow sulfur particles. So unlike sulfur dioxide, this test is given by sulfur dioxide also. But what is a major difference between both of them is the yellow particles. So if you get yellow particles, it is H2S, and if you don't get yellow particle, then it is sulfur dioxide. I hope this is clear. Let us move to the next question. Question number 19. Nitrogen dioxide is colorless and odorless, greenish yellow with pungent odor, reddish brown with irritating odor, and colorless gas with rotten egg smell. The correct option is reddish brown with irritating odor. Let me remind you, this is the second colored gas we are coming across. The first colored gas was chlorine. So this is the second colored gas, that is nitrogen dioxide. It turns moist blue litmus paper red. This statement proves that nitrogen dioxide is acidic in nature. Question number 20. Nitrogen dioxide turns potassium iodide paper brown because it forms nitric acid. It liberates iodine from Ki. It forms complex with Ki. It oxidizes Ki to KiO3. Yes, students, the correct option is it liberates iodine from Ki. Fine. Let us move to the next question. Question number 21. Nitrogen dioxide dissolves in cold water to form nitric acid only, nitrous acid only, mixture of nitrous and nitric acid, and ammonia. The correct option is mixture of nitrous and nitric acid. Why? The answer is nitrogen dioxide is called as mixed acid anhydride. I will request you to go through chapter 3 to know the meaning of acid anhydride. Let us move to the next question. Question number 22. Which gas turns moist red litmus paper blue? If it is red to blue, meaning it is basic gas. So the options are sulfur dioxide, carbon dioxide, ammonia, and hydrogen chloride. Answer is ammonia, because amongst the option this is only gas which is basic. The remaining gas is given in the options are acidic. And you know red litmus paper turns blue when it is basic. Let us move to the next question. Question number 23. Ammonia gas gives dense white fumes with dilute hydrochloric acid, concentrated hydrochloric acid, water, and oxygen. Yes, the correct option is concentrated HCl. Now these terms are very important, students. Concentrated and dilute. Dilute will not give this test, but concentrated will give. So if you don't write word concentrated, you might lose marks in the exam. So answer is concentrated HCl. When HCl comes in contact with ammonia, it's from ammonium chloride, which is dense white fumes. Let us move to the next question. Question number 24. When ammonia is passed through copper sulfate solution, initially pale blue PPT is formed. This precipitate is copper oxide, copper hydroxide, copper sulfate, copper chloride. The correct option is copper hydroxide. Copper hydroxide is an insoluble salt which is blue in color. It's a test for identification of cation copper. Let us move to the next question. Question number 25. When excess ammonia is passed through copper sulfate solution, the pale blue PPT dissolves to form colorless solution, deep blue or inky blue solution, green solution, brown solution. The option is deep blue or inky blue solution. Very common error done by student is they write inky blue PPT. It's not PPT, it's no more PPT in excess. PPT is copper hydroxide. Okay, when it dissolves, it forms a complex salt tetramine copper sulfate. which is deep blue solution. It's not PPT. So when you are writing the answer, kindly be very careful. Let us move to the next question. Question number 26. Nessler's reagent is alkaline solution of potassium mercuric iodide, acidified potassium permanganate, barium chloride solution, silver nitrate solution. Answer is alkaline solution of potassium mercuric iodide, and this Nessler's reagent is used for identification of ammonia gas. Let's move to the next question. Question number 27. With ammonia, Nessler reagent gives blue color, reddish brown PPT, green color, yellow solution. The correct option is reddish brown PPT. If this question is asked, no need to write the equation, only observation you can write. I hope students you understood the test of acidic gas, basic gas and neutral gas. In this slide I have covered, in this video I have covered neutral gases, acidic gases and basic gas and their test. I hope you'll revise once more from your text given by your school, and if you have liked my explanation, like, share and subscribe my channel. All the best.